Somewhere beyond the glowing galaxies and brilliant stars lies a part of the universe so empty, it almost shouldn't exist. These are cosmic voids, enormous regions of darkness stretching across hundreds of millions of light-years, where entire galaxies drift alone through near-total silence. For decades, scientists believed these voids were simply empty gaps in space. But hidden inside them are strange isolated galaxies, invisible rivers of dark matter, mysterious gas flows, and ancient dwarf galaxies barely detectable by modern telescopes. In tonight's journey, we'll explore the loneliest places in the cosmos, where stars are still born in complete isolation, where the cosmic web quietly threads through darkness, and where some of the universe's deepest mysteries may still be hiding. Relax, drift into deep space, and discover the most relaxing facts about void galaxies. The silent oceans of the universe. Far beyond the bright spiral galaxies and glowing nebulae lies one of the strangest regions in existence: cosmic voids. These enormous empty spaces are among the largest structures in the observable universe, yet they are almost completely invisible. If galaxies are cities of light, then cosmic voids are the endless dark oceans between them. Some voids stretch across hundreds of millions of light-years. Inside them, galaxies are incredibly rare. Imagine traveling through space for millions of years without seeing a single large galaxy nearby. The silence would be absolute. The darkness would feel endless. Scientists once believed these voids were simply empty gaps left behind as matter gathered elsewhere. But modern astronomy has revealed something far more mysterious. Cosmic voids are not truly empty. They contain faint traces of dark matter, thin streams of gas, tiny hidden galaxies, and weak gravitational forces quietly shaping the universe itself. The universe is organized like a giant cosmic web. Massive galaxy clusters sit along glowing filaments made of matter and gas, while enormous voids fill the spaces between them. From a distance, the structure resembles soap bubbles or neural networks inside a brain. Galaxies gather along the edges, while the centers remain eerily empty. What makes voids fascinating is how peaceful they are compared to crowded regions of space. In galaxy clusters, collisions and gravitational interactions constantly disturb stars and gas clouds. But inside voids, galaxies can evolve slowly for billions of years, almost untouched by outside forces. Astronomers often call these regions the quiet countryside of the cosmos. While crowded galaxies experience chaos, void galaxies drift in near isolation through some of the calmest environments imaginable. One of the most famous examples is the Boötes Void, sometimes nicknamed the Great Nothing. It is so large that if our Milky Way were placed inside it, astronomers might not discover another major galaxy for an incredibly long cosmic distance. The Boötes Void spans roughly 330 million light-years across, making it one of the largest known empty regions in space. Yet even within these enormous voids, strange galaxies survive. These are known as void galaxies, isolated galaxies that live far away from the dense cosmic web. Because they experience fewer collisions and less gravitational stress, they often evolve differently from galaxies in crowded regions. Many void galaxies continue forming stars long after similar galaxies elsewhere have slowed down. Some contain surprisingly pristine gas, almost unchanged since the early universe. Studying them is like looking back in time. Astronomers are especially interested in how dark matter behaves inside cosmic voids. Dark matter cannot be seen directly, but its gravity influences the motion of galaxies and gas. Even in the emptiest regions of space, dark matter quietly shapes invisible structures that may guide the movement of isolated galaxies. Some simulations suggest that tiny hidden filaments of dark matter stretch across voids like faint spider webs. Along these invisible threads, small dwarf galaxies may slowly drift through darkness over billions of years. The emptiness itself also changes the way galaxies behave. In crowded regions, supermassive black holes can become highly active due to frequent mergers and flowing gas. But in void galaxies, black holes may remain quieter and less violent. Without constant disruptions, the galaxies evolve in calmer, slower ways. This isolation gives astronomers a rare opportunity. By studying void galaxies, scientists can observe how galaxies might naturally evolve without interference from neighboring systems. Some void galaxies also appear surprisingly blue. Blue light often indicates ongoing star formation, meaning new stars are still being born inside these isolated regions. The galaxies quietly continue building themselves while much of the universe around them remains dark and empty. Even more mysterious are the faint dwarf galaxies hiding deep inside voids. These tiny galaxies are difficult to detect because they contain very few stars. Some may hold clues about how the first galaxies formed shortly after the Big Bang. Astronomers believe there could be countless undiscovered dwarf galaxies floating inside cosmic voids, too dim for current telescopes to easily observe. The deeper scientists study these empty regions, the stranger they become. Voids may influence the expansion of the universe itself. Some researchers even investigate whether voids affect measurements of dark energy, the mysterious force causing cosmic expansion to accelerate. In a universe filled with explosions, quasars, black holes, and violent collisions, cosmic voids offer something very different: stillness. These silent regions remind us that emptiness itself can hold extraordinary mysteries. And somewhere inside that darkness, isolated galaxies continue drifting quietly through the largest deserts the cosmos has ever created. The lonely galaxies hidden inside cosmic voids. Among the most mysterious objects in the universe are galaxies that live almost entirely alone. These are known as void galaxies, isolated systems drifting through enormous regions of near emptiness, separated from other galaxies by unimaginable distances. In crowded parts of the universe, galaxies constantly interact. They collide, merge, steal gas from one another, and trigger violent bursts of star formation. But inside cosmic voids, many galaxies avoid these chaotic encounters for billions of years. Because of this isolation, void galaxies evolve differently from almost everything astronomers normally observe. Some of these galaxies appear unusually calm and delicate. Their spiral arms remain thin and undisturbed, unlike galaxies that have been twisted by repeated collisions. Others contain massive reservoirs of cold hydrogen gas that still fuel the birth of new stars even after billions of years. Astronomers sometimes describe void galaxies as cosmic time capsules. Since they experience fewer disruptions, they may preserve conditions similar to those found in the younger universe. One of the strangest discoveries is that certain void galaxies continue producing stars at surprisingly high rates despite their isolated surroundings. In denser regions of space, galaxies often lose their gas supply over time. Nearby galaxies, black holes, and galaxy clusters can strip material away through gravity and radiation. But inside voids, galaxies can quietly hold onto their gas for enormous periods of time. This allows some void galaxies to remain blue and active while older galaxies elsewhere slowly fade into red, quieter systems. The blue glow comes from hot young stars constantly forming inside giant clouds of hydrogen gas. The isolation of void galaxies also changes the behavior of supermassive black holes. In crowded galaxies, black holes often become highly active when collisions funnel gas toward the galactic center. This creates powerful quasars and enormous jets of radiation. But in many void galaxies, the central black holes appear calmer and less aggressive. Without frequent mergers, the black holes may grow more slowly, producing quieter galactic environments overall. Astronomers are fascinated by how peaceful these systems can remain over cosmic timescales. Some void galaxies may have spent billions of years evolving almost entirely undisturbed. Even their shapes can look unusual. Researchers have discovered ring-shaped galaxies, stretched galaxies, and faint irregular systems hidden inside voids. Some seem to rotate differently from galaxies in dense environments. Others contain strange distributions of gas that do not fully match current models of galaxy evolution. This suggests that the emptiness itself may influence how galaxies form and behave. Void galaxies also challenge older theories about the large-scale structure of the universe. Early models predicted that large voids should contain very few galaxies at all. But modern surveys continue uncovering faint systems hidden deep inside these regions. Many are tiny dwarf galaxies. Dwarf galaxies are among the smallest galaxies in existence, often containing only a few million stars instead of hundreds of billions like the Milky Way. Because they are faint and difficult to detect, scientists suspect enormous numbers of them may still remain undiscovered inside cosmic voids. Some dwarf galaxies may even travel along invisible streams of dark matter stretching through the emptiness. Dark matter plays a critical role in the story of void galaxies. Although it cannot be seen directly, dark matter creates gravitational scaffolding throughout the universe. Galaxies form where this invisible matter gathers together. Even inside the emptiest voids, weak dark matter filaments may quietly guide the motion of isolated galaxies. Computer simulations suggest the cosmic web never completely disappears. Instead, tiny hidden structures continue threading through the darkness like faint veins across the universe. Gas may slowly flow along these invisible pathways into isolated galaxies, allowing star formation to continue for billions of years. Some astronomers believe these gas flows could explain why certain void galaxies remain surprisingly active despite their loneliness. There are also signs that void galaxies may contain fewer heavy elements than galaxies in crowded regions. Heavy elements are created inside stars and spread through supernova explosions. In dense regions, galaxy interactions recycle these materials efficiently. But isolated galaxies may evolve more slowly chemically, preserving ancient cosmic conditions. Studying these galaxies is almost like studying fossils from the early universe. The deeper telescopes peer into cosmic voids, the more mysterious these lonely galaxies become. New instruments are beginning to reveal extremely faint structures once completely invisible to astronomers. Some scientists even suspect there may be entire populations of ultra-dim galaxies hidden inside voids beyond current detection limits. These hidden systems could help answer some of cosmology's biggest questions, including how galaxies first formed and how dark matter shaped the universe after the Big Bang. Far away from crowded galaxy clusters and brilliant quasars, void galaxies continue drifting silently through the darkest regions of existence. Alone, isolated, and almost forgotten by the rest of the cosmos, they may hold some of the oldest secrets in the universe. Dark matter rivers and the invisible cosmic web. Although cosmic voids appear empty at first glance, scientists now believe they are filled with something almost impossible to see: invisible structures made of dark matter. Dark matter is one of the greatest mysteries in modern astronomy. It does not emit light, reflect light, or absorb light. Telescopes cannot directly observe it. Yet its gravity shapes galaxies, bends light across space, and controls the large-scale architecture of the universe itself. Without dark matter, galaxies might never have formed at all. Astronomers estimate that ordinary matter, stars, planets, gas, and everything humans can see, makes up only a small fraction of the universe. Most of the cosmos is composed of dark matter and dark energy, both still largely unexplained. Inside cosmic voids, dark matter behaves in particularly strange ways. At first, scientists imagined voids as giant empty bubbles with almost no structure. But advanced computer simulations began revealing something unexpected. Even the emptiest regions of space contain faint threads of dark matter stretching across unimaginable distances. These hidden structures form part of the cosmic web. The cosmic web is the enormous framework connecting galaxies across the observable universe. Massive galaxy clusters sit where dark matter filaments intersect, while giant voids open between them like enormous cosmic cavities. From far away, The universe resembles a vast three-dimensional spider web glowing faintly across the darkness. Inside the denser filaments, gravity pulls gas together to create galaxies and stars. But inside voids, matter becomes incredibly thin and spread apart. Even so, the web never fully disappears. Tiny rivers of gas and dark matter may continue flowing through the darkness for billions of years. Astronomers sometimes compare these flows to underground currents moving beneath a calm ocean surface. Invisible streams quietly transport hydrogen gas across deep space, occasionally feeding isolated galaxies hidden inside voids. These gas flows may explain one of the biggest mysteries surrounding void galaxies: how some continue forming stars despite their isolation. Normally, galaxies require enormous amounts of cold gas to create new stars. In crowded environments, galaxy collisions and nearby activity constantly redistribute gas. But inside voids, there are far fewer interactions. Yet many void galaxies still contain active star-forming regions. Scientists suspect that faint dark matter filaments guide cold hydrogen gas directly into these isolated galaxies, slowly supplying them with fresh material over cosmic timescales. In some simulations, these gas streams appear like glowing rivers threading silently through darkness. The existence of these invisible structures also changes how astronomers think about emptiness itself. A cosmic void is not truly empty. Instead, it may contain extremely faint matter distributions too difficult for current instruments to fully detect. Some researchers believe entire hidden networks of dwarf galaxies could exist inside these regions, quietly following dark matter pathways. New radio telescopes are beginning to search for these nearly invisible structures. One important clue comes from gravitational effects. Even when dark matter cannot be seen, its gravity slightly changes the motion of galaxies and bends the path of light traveling across space. By carefully studying these distortions, astronomers can map parts of the hidden cosmic web. It is almost like observing the shadow of something invisible. Some of the universe's faintest galaxies may survive only because dark matter halos protect them gravitationally. These halos act like invisible cocoons surrounding galaxies, helping them hold onto gas and stars even in isolated environments. Without dark matter, many tiny galaxies might simply drift apart. Scientists also believe dark matter influenced the formation of the first galaxies shortly after the Big Bang. In the early universe, ordinary gas gathered around dense pockets of dark matter, eventually igniting the first stars. The same invisible physics may still shape void galaxies today. One fascinating possibility is that dark matter behaves differently inside low-density environments like voids. Certain theories predict subtle changes in gravity or particle interactions where matter becomes extremely sparse. If true, cosmic voids could become natural laboratories for testing new physics. Astronomers are now using powerful observatories to study the edges of voids in extraordinary detail. The boundaries between crowded galaxy filaments and deep emptiness may contain important clues about how dark matter flows through the universe. Some researchers even suspect that the expansion of cosmic voids may influence how the universe itself expands over time. As space grows larger, voids continue widening, pushing galaxies farther apart. In a sense, the universe is becoming emptier with age. Over billions upon billions of years, cosmic voids may eventually dominate the large-scale structure of the cosmos. Galaxies beyond our local group could slowly disappear from view as space expands faster and faster. Future civilizations might look into the sky and see only darkness surrounding their own isolated galaxy. The cosmic web that astronomers observe today could eventually become invisible. For now, however, hidden rivers of dark matter still connect distant galaxies across unimaginable expanses of space. And inside the deepest voids of the universe, invisible structures continue shaping galaxies that drift silently through eternal darkness. Star formation in the loneliest places in the universe. Deep inside cosmic voids, far away from crowded galaxy clusters and violent cosmic collisions, stars are still being born. This surprises many astronomers. At first glance, void galaxies seem too isolated to remain active for billions of years. In the denser regions of the universe, galaxy interactions often trigger waves of star formation by compressing giant clouds of gas. Without these interactions, scientists once believed isolated galaxies inside voids would slowly fade into darkness. But the universe turned out to be far stranger. Many void galaxies continue producing new stars quietly and steadily, even in some of the emptiest regions ever discovered. These galaxies often glow with a soft blue light, a sign of young, hot stars. Blue stars burn extremely brightly but live relatively short lives. Their presence means star formation is still actively happening inside these isolated systems. Some void galaxies appear younger than expected because they continue building new generations of stars long after similar galaxies elsewhere have slowed down. The secret lies in hydrogen gas. Hydrogen is the primary ingredient needed to create stars. When enormous clouds of cold hydrogen collapse under gravity, temperatures rise until nuclear fusion begins. A new star is born. Inside crowded galaxy clusters, galaxies frequently lose gas through collisions, radiation, or gravitational stripping caused by nearby systems. But inside cosmic voids, isolated galaxies can often keep their gas reservoirs for enormous periods of time. This allows star formation to continue slowly and peacefully across billions of years. Astronomers studying void galaxies sometimes describe them as quiet stellar nurseries. Unlike chaotic starburst galaxies, where thousands of stars may form rapidly during violent mergers, void galaxies often create stars at calmer, more stable rates. The process resembles a slow cosmic heartbeat. Some isolated galaxies contain gigantic disks of hydrogen gas extending far beyond their visible stars. These invisible gas halos act like enormous fuel tanks, quietly sustaining star formation far into the future. Radio telescopes are especially important for detecting these hidden hydrogen clouds. Ordinary optical telescopes mainly observe stars and visible light, but radio astronomy can reveal the faint signals emitted by cold hydrogen drifting through space. These observations show that some void galaxies contain surprisingly large amounts of unused gas. Even more mysterious are galaxies that seem to awaken after long periods of quiet evolution. In certain cases, weak streams of gas flowing through the cosmic web may slowly feed isolated galaxies. Over millions of years, this incoming gas can trigger fresh waves of star formation even without galaxy collisions. Invisible rivers of matter may quietly sustain life inside the universe's loneliest regions. Some void galaxies also rotate differently from galaxies in crowded environments. Because they experience fewer interactions, their internal structures can remain unusually stable for very long periods. This stability may help preserve delicate spiral arms and thin gas disks that would otherwise be disrupted in dense cosmic neighborhoods. Astronomers have even found evidence that certain void galaxies form stars in unexpected outer regions far from their galactic centers. Normally, star formation is strongest near the dense central areas of galaxies where gas concentrations are highest. But in isolated systems, stars can sometimes emerge across enormous extended disks of gas stretching through space. These distant stellar nurseries glow faintly against the surrounding darkness. Void galaxies may also contain fewer heavy elements than galaxies in crowded regions. Every generation of stars creates heavier elements like oxygen, carbon, silicon, and iron. When stars explode as supernovae, these elements spread into surrounding gas clouds, enriching future generations of stars and planets. But in isolated galaxies, this chemical evolution often happens more slowly. As a result, some void galaxies preserve more primitive cosmic conditions similar to those found earlier in the history of the universe. Studying these galaxies helps astronomers understand what the first generations of galaxies may have looked like shortly after the Big Bang. Some scientists believe void galaxies could offer clues about how star formation behaved before the universe became crowded with large galaxy clusters. There are also signs that dwarf galaxies inside voids may experience bursts of star formation separated by extremely long quiet periods. Because these tiny galaxies have weak gravity, even small changes in gas flow can dramatically affect their evolution. A single stream of incoming hydrogen may ignite new waves of star birth after hundreds of millions of years of silence. The isolation of void galaxies also affects supernova explosions. In crowded regions, shockwaves from nearby galaxies and intergalactic activity constantly disturb surrounding gas. But inside voids, supernova remnants may expand more quietly through thinner interstellar environments. Everything evolves more slowly in cosmic emptiness. Even time itself seems calmer inside these isolated regions. Future observatories may reveal thousands of previously hidden void galaxies still quietly forming stars in darkness. Some may contain extremely faint stellar populations invisible to current telescopes. Others may represent ancient galactic systems that have barely changed for billions of years. Far away from crowded cosmic cities, these lonely galaxies continue lighting tiny candles against the vast darkness of the universe. And within the deepest voids ever discovered, stars are still quietly being born. Hidden dwarf galaxies and the deepest mysteries of empty space. For a long time, astronomers believed cosmic voids were nearly empty, vast regions containing very few galaxies and little activity. But as telescopes became more sensitive, scientists began discovering something unexpected hidden inside the darkness. Tiny galaxies were everywhere. These systems are known as dwarf galaxies, and they may be among the most important objects in the universe. Although they are much smaller and dimmer than giant spiral galaxies like the Milky Way, dwarf galaxies could hold clues to some of cosmology's greatest mysteries. Many of them drift silently through cosmic voids almost completely unnoticed. A dwarf galaxy can contain only a few million stars, while large galaxies may contain hundreds of billions. Some dwarf galaxies are so faint that detecting them is extremely difficult even with powerful modern telescopes. Against the enormous darkness of cosmic voids, they become almost invisible. Astronomers suspect that countless hidden dwarf galaxies still remain undiscovered deep inside these regions. Some may be little more than faint clouds of stars loosely held together by dark matter halos. Others could be ancient galactic fossils dating back close to the beginning of the universe itself. Because dwarf galaxies are small, they are highly sensitive to their environments. In crowded regions of space, larger galaxies often tear them apart through gravity. Many dwarf galaxies are absorbed completely during galactic mergers. But inside cosmic voids, some dwarf galaxies may survive undisturbed for billions of years. This isolation makes them incredibly valuable to astronomers. By studying dwarf galaxies in voids, scientists may be able to observe galactic conditions similar to those that existed shortly after the Big Bang. Some isolated dwarf galaxies appear chemically primitive, meaning they contain very low amounts of heavy elements. This suggests they have experienced relatively little stellar evolution over cosmic history. In a way, these galaxies are like frozen relics from the young universe. One major mystery involves the so-called missing dwarf galaxy problem. Computer simulations predict the universe should contain far more dwarf galaxies than astronomers currently observe. Where are they? Some researchers believe many missing dwarf galaxies could be hidden inside cosmic voids, too faint and diffuse for current instruments to easily detect. Future telescopes may finally reveal these invisible populations. Dark matter plays a crucial role in this mystery. Scientists believe dwarf galaxies form inside small dark matter halos, invisible regions of gravitational influence that help gather gas and stars together. Even when very few stars are present, dark matter may continue holding these tiny systems intact. Without dark matter, many dwarf galaxies might never have survived. Some astronomers suspect there may even be dark galaxies drifting through cosmic voids, objects made mostly of dark matter and gas with very few visible stars at all. These hypothetical galaxies would be almost impossible to detect directly. If they exist, they could reshape our understanding of galaxy formation completely. Cosmic voids may also hide faint structures connecting tiny galaxies across enormous distances. Weak filaments of gas and dark matter could form invisible bridges stretching through the darkness. Along these hidden pathways, isolated dwarf galaxies may slowly drift over billions of years. The deeper scientists explore voids, the more complicated the emptiness becomes. Some observations even hint that voids themselves may affect the expansion of the universe. The universe has been expanding ever since the Big Bang, but scientists discovered that this expansion is accelerating. The unknown force responsible is called dark energy. Cosmic voids may help researchers study how dark energy behaves on the largest scales imaginable. Because voids contain relatively little matter, they allow astronomers to observe cosmic expansion with fewer gravitational disturbances. Some researchers think these empty regions could provide important clues about the true nature of dark energy itself. In the distant future, cosmic voids may become even larger. As the universe continues expanding, galaxies will drift farther apart. Over unimaginable spans of time, more regions of space may become isolated and dark. Future civilizations could find themselves trapped inside lonely galaxies surrounded by emptiness, unable to observe the wider cosmic web that exists today. The universe may slowly become quieter and darker with age. Yet even in these immense regions of near-nothingness, mysteries continue hiding. Tiny galaxies still form stars. Invisible dark matter still shapes the motion of matter. Faint gas streams still flow silently through deep space. And somewhere inside the largest voids ever discovered, ancient galaxies continue drifting through darkness almost completely alone. Cosmic voids remind us that emptiness is never truly empty. Sometimes the quietest places in the universe contain the deepest mysteries of all.